types of equations. Identifying types of equations. Now, we've dealt with 3 main types of equations so far. Okay, we've dealt with 3 main types of equations. What's our first type that we use today? Again, what type of equation is that? Linear. Okay, so our first type we're going to talk about is linear. What is our second type of equation that we've talked about? Starts with a Q. Quadratic. That's our second type we've talked about over the last 5 lessons. And then our last one, Cora? Exponential. Okay, so we have those 3 main types of equations. Now, there are, of course, other types that we have yet to talk about. There's absolute value. There are rational equations. There are all different types. Okay, a bunch we won't even get to in Algebra 1. These are the 3 main ones that we'll get to. Okay. So we've talked a little bit now today already about linear. What's our main form that linear comes in? Y equals mx plus b. That's our main form. Okay, that's our slope-intercept. We also have our standard form, which is ax plus by equals c. But linear is not just limited to those types, or that exact setup. Linear, there's 2 things that we want to identify to make sure an equation is a linear equation. Okay. So those things that we want to identify is that there are 1, no exponents. Okay. Meaning everything there is to the first power. So, and specifically our variables. Okay. This has to be just a regular x. It cannot be x squared or x cubed. Okay, has to be just regular. Okay, to the first power. Our second thing that we need to identify, or need to make sure, is that linear equations can have no exponents, no variables. No variables in a denominator. Now, what is a denominator? Very good. It's the bottom part of a fraction. So there will be equations sometimes where you'll see something like y equals 2 over x. Okay, that is what's referred to as a rational equation. That is not linear, even though there's no exponent there. Okay, it's got that x in the denominator. So those are the 2 things that you want to identify when we have a linear equation, on whether it's linear or not, if we have it in just the equation form. Okay. The other thing we want to look at is what the graphs of linear equations look like. So with the linear equation, our graph is always a what? Huh? Straight line. Straight line. Okay, those can be slanting up, they can slant down, they can be straight across. Anytime we have a straight line, that is a linear equation. Okay. Yes?
What if we have one straight line and they have lines that go down and increase?
Okay, so those are our linear piecewise functions.
Like,
So it's still linear. The piecewise tells us that it's different based on what interval we're at. Okay, so those are a little bit different than linear equations, in that it is going to change depending on where you're at in the problem. We don't just have one set equation for that. Okay. Don't necessarily worry about that for right now. Just kind of remember that. Okay. These are the three types we're going to focus on. Okay. So that's our linear equations. No exponents, no variables in a denominator. Okay. And it's going to make a straight line of some sort. Okay. So let's look at our quadratic next. Okay. Now we very briefly talked about our quadratic equations and how they look. But if you remember, our most basic would be y equals x squared. That's what's called our parent function of our quadratics. A lot of times you'll see it as something like y equals x, 2x squared minus 3x plus 5. Okay, that is a quadratic equation. Okay. The way we tell whether something is quadratic or not is that we have a variable to the second power. Okay. We have a variable to the second power. So in each of these cases, y equals x squared, we have x to the second power. Okay, that's what we're looking at. If there's any other variables that are higher, so if we, if they slipped in an x to the third or something like that, it would no longer be quadratic. Okay. They have, if it's x to the third, there's a cubic function. We want to see just x squared somewhere in that problem. So our graphs with these, depending on what part you are going to see, we have, our graph should either look like a U, okay, this would be a positive quadratic function. Okay. It could also be the opposite way. This is a negative quadratic function. Okay. You can open up for positive or open down as a negative. We've also, and the ones we looked at with the diver that was jumping from the really high pole into the shallow water, we only saw one half of his equation. Okay, so we saw him jump up slightly and come down. Okay, this was an example of a quadratic equation, but we only saw part of it. Okay, so we could, if we wanted to, we could extend his equation down back the other side, and it would basically turn on itself. Okay, but sometimes we're only going to see that one half. Okay, so the main thing that we want to identify from these, okay, because this will be a quiz question, hint, hint. Will be a quiz question, hint, hint. Hint, 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 hint. Okay. So, we already know that we have a variable to the second power. Something else we want to know about these graphs. Okay. Is that the graph curves back towards its start. Okay, so what do we mean by that? Is that with these graphs, if we're starting from left to right, starting low, coming up high, and then it's going to curve back down low. Okay, same way with the top one here. It started out high, we came down, and then curved back up. Okay, so the graph curves back towards its start. In other words, if it helps you think of it, it turns around. Or makes a U-turn. U-turn. Okay? So,